Today we're at the Coastal Studies Institute doing a meet and greet as part of the DOE Waves to Water competition. This is a really exciting opportunity for the public to come in, learn a little bit from the actual innovators that have designed these devices that can use wave energy to convert salt water for fresh water. The devices that you see around, these teams have put together these innovative devices that will be deployed off the end of Jeannette's Pier for 5 days in the final competition in a 5-stage Department of Energy sponsored $3.2 million prize competition to see how much and the quality of water that they can create using only wave energy. All of that's going to be done off of Jeannette's Pier here on the Outer Banks.
I'm Gilbert from Onica Technology, and we are here to present the Onica Snowflake device, and we're glad to see so much people over here and just to present all the solutions that the 4 teams has to present for something that is very important, which is getting fresh water for everybody. Every device is very different. There's electric, there's purely mechanical like ours, there's self-actuated devices, there's a smaller one but easier to install, so we'll see which one gets the most out of it and win the competition.
Behind me is our device, which is a wave-powered attenuator. And all an attenuator means is that it's a long hinge device that oscillates in the seaway, and it pumps salt water through it and makes fresh water. Wave energy is kind of the underdog between some of the other options. You have to really push hard on it to make progress happen because it's very unforgiving. The conditions are hard, the energy density is small. You have to have some driving force to make people move this technology forward.
We've got NREL, the National Renewable Energy Laboratory, that had made their own device. We've got a group from NC State that's showing some of their instruments that they've put together, their devices for harnessing the energy of the ocean. Their work is focused on currents. It's this opportunity to come and learn a lot more about North Carolina's Renewable Ocean Energy Program, about the Department of Energy, their operations and what they're doing to think about the energy found in the ocean, how we can harness it, how we can use it, in this case as part of this competition, how we can use ocean energy to convert salt water to fresh water, a resource that we all need in coastal communities around the globe.
Disaster response is incredibly challenging because you don't have electrical infrastructure, you don't have the infrastructure for water, and so having a device like this can be rapidly deployed and easily deployed by a few people. I think it could have a really important impact to helping people in a disaster area.
So our device is focused on being lightweight, portable, easily deployed, and simple. So we've got something that can be transported by 4 people by hand, fits in the back of a pickup, goes through standard doors, and can be rapidly deployed to desalinate water in the event of a disaster. As far as what drew us to the challenge, access to fresh water is important. It's important for life, and there are a lot of communities where that's not a given. And then from an engineering point of view, it's a tough challenge. The ocean is a pretty tough environment to work in, so it's nice, intellectually stimulating and challenging. It's a chance to put together a really high quality team and work on an important project.
Fresh water is a resource that's needed throughout the world. These devices are all in one container that can be pulled out, constructed, put in the water, and using the energy from waves to create fresh water.